Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 8 video on the chapter of squares and square roots, I will solve the exercise 3H, which are objective questions, and there are 19 multiple choice questions, and ideally you should be able to solve this question as a test in 60 minutes, 45 to 60 minutes, that is approximately 3 to 4 minutes per question. So this video, if you have not watched the all my theoretical videos, that is part 1 to part 7, where I have covered the entire chapter squares and square roots, then I highly suggest that you please watch them so that your preparation on the chapter of squares and square roots is complete. This video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time, if this is your first video you are watching and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the problems of exercise 3H. Okay, so I have the problems of exercise 3H on the left hand side. There are 19 questions and all of them I guess are MCQ questions. You have 4 choices A, B, C, D, and 1 choice will be correct. On the right hand side I will solve the problems. Let me quickly check if everything is visible or not. I hope you can read the problems. Let me zoom in a little bit the problems. So it is always recommended that you try to solve the problems of MCQ or sample test given at the end of every chapter yourself first, and if you are stuck, then you are always welcome to see this my solution video. And I also recommend you to watch my theoretical videos where I thoroughly discuss about all the concepts of every chapter. So for class 8, this is the chapter. I have just completed the chapter on squares and square roots. Okay, let's start solving the problems. Problem number 1, which of the following numbers is not a perfect square? We know that any number which ends with the 4 digits 2, 3, 7, 8 cannot be a perfect square. So the choice is obviously C, because answer is C. Answer is C, as 5, 4, 7, 8 ends with the digit 8. Any number that ends with the digit 2, 3, 7 or 8 cannot be a perfect square. Okay. So while I am solving the problem, you can pause the video for long questions. For lengthy computational problem, you can pause the video and take a screenshot for your future reference. Question number 2 says, which of the following numbers is not a perfect square? Okay, so the numbers is not a perfect square. Now again you can see that the obvious choice is since these are multiple choice questions and only one choice will be correct, obviously we can say that the number 2222 cannot be a perfect square because it ends with the digit 2. So we don't even need to check the other numbers. So the answer is choice D, as 2222 ends with the digit 2. So any number ending with the digits 2, 3 or 7 or 8 cannot be a perfect square. This is a property of a square number. Okay. Let's do problem number 3. Which of the following numbers is not a perfect square? Again, obviously the answer is The answer is A, because the number given is 1843. 1843 ends with the digit 3, and we know that any number ending with digit 2, 3, 7, 8 cannot be a perfect square. So question number 3 is answer A. Choice A is the correct answer. Question number 4 is, which of the following numbers is not a perfect square? Now, these first 4 questions are really easy peasy, because it is obvious that question number 4 in all these problems, that the number, if any number is ending with the digits 2, 3, 7 or 8, it cannot be a perfect square. So question number 4 answer is B, as 4, 7, 8, 7 ends with the digit 7. Okay. Question number 5. Question number 5. Which of the following numbers is not a perfect square? Again, which of the following numbers is not a perfect square? Okay, so now we can see that all the numbers are 0. We know that if a perfect square number, if it ends with 0, then it has to end with even number of zeros. Even number of zeros. Choice A is 3600, it has even number of zeros. Choice B is 6400. Choice C has 3 zeros. So the correct choice is C, as the given number 81000 ends with odd number of zeros. If a number is a perfect square and it has to end with zeros, then the number of zeros should be, it has to end with the even number of zeros. Okay. Problem number 6. Which of the following cannot be the unit digit of a perfect square number? Which of the following cannot be the unit digit of a perfect square number? Okay, so it is asking, if a number is a perfect square number, what is the digit, then which of the following digit it cannot have as the unit digit? That is the ending digit or the rightmost digit or the digit at the units place. And we know that the answer, those digits are 2, 3 and 7, 8. So we have to choose the choice which is any one of those 4 digits, that is 2, 3, 7 or 8. So the correct choice is D. Okay. Question number 7. Okay. Question number 7. The square of a proper fraction is, okay, larger than the fraction, smaller than the fraction, none of these equal to the fraction. This is a property about the square of a proper fraction, that we know that a by b, if a by b is a, it is talking about a proper fraction, not improper fraction. A by b, the square will always be less than the fraction itself, where a by b is a proper fraction, that is, a, the numerator, should be less than the denominator. So the correct choice is smaller than the fraction. So the answer is choice B. Okay, let's do problem number 8. Now, it is highly possible that I won't be able to solve any one of these problems because I have forgot the concepts. I mean, even though I have recently completed the chapter on squares and square numbers, it is not the case that I remember all the concepts. So that is a possibility. Anyway, let's try my best. So if n is odd, question number 8, if n is odd, then 1 plus 3 plus 5 plus 7 up to n terms. That is, it is 1 plus 3 plus 5 plus 7 means these are the summation of odd numbers, consecutive odd numbers, and up 1 plus 3 plus 5 plus 7. So 1 plus 3 plus 5 plus 7. It is said 2 n terms. 2 n terms means there are n terms. N terms. First term is the 1, second term is the 3, third term is the 5, fourth term is the 7. So there are like this n terms. N terms. This implies this is sum of first n odd positive integers. Up to n terms means this is the sum of first n odd positive integers, and we know that its value, we know a formula, its value is n square. Its value is n square. So the answer is choice C. The answer is choice C. Okay. Question number 9. Which of the following is a Pythagorean triplet? Which of the following is a Pythagorean triplet? We know that x, y, z, the concept is x, y, z is a Pythagorean, triplet if we have z square is equal to x square plus y square. This is the concept of Pythagorean triplet. So now we have to check all the options which is satisfying this property. Now let's see the choice A. Are we having 5 square equals to 2 square plus 3 square? This implies 25 is equal to 4 plus 9 equals to 3. This is wrong. This is wrong. So 25 is not equals to 13. Okay. Choice B. The given triplet is 5, 7, 9. So we must have 9. We must have 9 square is equal to 5 square plus 7 square. This implies 81 should be equal to 25 plus 49. This is equal to 74. This is also false. Choice B is also wrong. 5, 7, 9 is not a Pythagorean triplet, as the property is not satisfied. Let's see about the choice C, 6, 9, 11. So if it is a Pythagorean triplet, we must have 11 square equals to 6 square plus 9 square. This implies 11 square is 121. This should be equal to 6 square is 36 and 9 square is 81. And 36 plus 81 is equal to 117. This is also not true. 121 is not equal to 117. Okay. What is choice D? Choice D is 8, 5, 15, 17. So we must have 17 square equals to 8 square plus 15 square. This implies 17 square is 289, must be equal to 8 square is 64 and 15 square is 225. This is equal to 289. So this is correct. 289, 17 square is equal to 8 square plus 15 square. So the answer is choice D. The answer is choice D. Okay. Uh, Question number 10. What least number must be subtracted from 176 to make it a perfect square? What least number must be subtracted from 176 to make it a perfect square? Okay, so we have done this kind of problem in the theoretical videos. So it is the number given is 176. What least number must be subtracted from 176 to make it a perfect square? Okay, so we have to, by long division method, we have to find the square root. So when we create the periods, that is pair of two digits starting from the right hand side, so we have 76 and 1, and when we do the long division method, starting from the leftmost period, which is 1, obviously it will be 1 1 1, remainder is 0. We bring down the next period, 76, the remainder is 76, which becomes the next dividend, and the next divisor, partial divisor, will be the current quotient, which is 1 multiplied by 2. Now we have to put a digit over here, x, such that the two digit number 2x multiplied by that digit should be less than equal to 76. So this implies, what can x be? X can be 3. Can x be 4? No, 3. So x is equal to 3, and so we have to put x equals to 3 over here, and 3 will get appended to the question, and 23 multiplied by 3 is 69. We have to subtract that from the current dividend, and we have 7 as the remainder, and there are no more periods. So 7 is the remainder. So now the question is, what least number must be subtracted from 176? Now, whenever you have this kind of, this kind of long division to find the square root of a number, what does this mean? The quotient is 13 and the remainder is 7. This implies that 13 square plus 7 is equal to 176. Always remember that if you do a long division to find a square root, and you have so something like this, whatever this is a number, and let's say you are doing a division, and the final remainder is r, and the final quotient is q. Let's say this be the number n, this be a number n. You are finding the square root of n using the long division method, and after a lot of steps you have found the the final quotient is q and the remainder is r. This implies that q square plus r is equal to n. Now, so q square, so now so this will imply from here, for this problem, 13 square is equal to 176 minus 7, or in this case, q square is equal to the given number minus the remainder. So 13 square, so definitely, so 176 minus 7 will be a perfect square. Now the question is, what least number must be subtracted? A number has to be subtracted. So we can clearly see that if we subtract 7 from 176, we are getting a perfect square, and that perfect square is the square of 13. Now how do we ensure that 7 is the least number? It is the least number because it is the concept of remainder. If when you do a division, whether you are doing a long division or just simple division, whatever the remainder is, that remainder is the least number that you can subtract from the given number, so that after subtraction, the number will be divisible by the divisor. So in the case of finding square root using the long division method, always remember that if you have a remainder, that remainder will always be the least number that you can subtract from the given number to get a number which is a perfect square. So 7 is the answer. 7 is the least number that should be subtracted from 176 to make it a perfect square, and that perfect square is 13 square. So choice. So question number 10. The answer is choice C. So it is choice C. Okay. Let's do problem number 11. Okay. 11 says what least number must be added to 526 to make it a perfect square. So question number 11, this is the same as question number 10, but this time you have to tell what is the least number that must be added. Okay. So first we have to do the given number, we have to find using the long division method. We have to find the we have to perform the long division method to find the square root, that is the quotient, and the remainder. So 526, we create the periods 26 and 5, and then we start the long division method. We start from the leftmost period, which is 5. So obviously the divisor will be 2. 2 into 2 is 4. Remainder is 1. Then we bring down the next period 2, 6. The remainder, the next dividend becomes 126. Then the next divisor, next partial divisor will be the current quotient, which is 2 multiplied by 2, that is 4. Now I have to add a digit x over here after 4, such that 4x, the 2-digit number 4x multiplied by x, should be less than equal to the dividend, that is 126. From here we have to find x. What can be x? X cannot be 3, because if x is 3, then it is becoming 43 into 3 is 129. So x has to be 2. X has to be 2, and 42 into 2 we know is 84. Okay, so x will be 2. I am replacing x with 2, and this 2 will also be appended to the current question. So we have 22, and 42 into 2 is 84. We subtract that from the current dividend to get the remainder, which is 2 and 2. Okay, 42. Okay, now the question is what least number must be added to 526. Now what number we must add. Now if the question was what is the least number we can subtract, that need to be subtracted from 526 to make it a perfect square, the answer would have been 42. But it is asked what least number we must add to 526. Now we clearly see, now from here we see that 22 square is equal to 526 minus 42. So that is this implies that 22, obviously 22 square will be greater than 526. 22 square is equal to 526 minus 42. So obviously 22 square is greater than 526. And also note that also 23 square will be greater than 23 square will be 22 square is not greater than 526, but 22 square is less than 526. And also if we take the we see that what does this long division says, that the quotient is 22 and the remainder is 42. It means that if we take the whole square of the quotient, then whatever that number is, that whole square number plus the remainder is the given number. is the given number. So 22 whole square is 526 minus 42. So obviously 22 square is less than 526, and we also know that 23 square will be greater than 526. 23 square will be greater than 526. So we are having that the given number 526 is greater than 22 square, but it will be less than 23 square. So it is asking what is the least number that must be added. Now so definitely we have to find. Now we see that 22 and 23 are consecutive numbers. 22 and 23 are consecutive numbers. So consecutive 22 and 23 are consecutive numbers. So 22 square and 23 square are consecutive perfect squares. So any number. So the question is asking, that is what least number must be added to 526 to make it a perfect square. That perfect square has to lie between 526 and 23 whole square. And we know that between 526 and 23 whole square, there cannot be any number there cannot be any number which is a perfect square. So the next number after 526 which is a perfect square has to be 23 square. Therefore, you can say this implies next perfect square greater than 526 is 23 square. Therefore, this should be the least number. Therefore, the least number to be added is x, such that is x. If we assume that the least number to be added is x, then we will have 526 plus x has to be equal to 23 whole square. Now 23 whole square is how much? 23 it is 69 multiplied by 46, that is 9, 12 and 529 plus 46. Okay, 529. So this is 529. So this implies, from here we can say that x is equal to 529 minus 526, which is equal to 3. So 3 is the least number that need to be added to 526 to make it a perfect square, and that perfect square will be 23 square. Okay. So the correct choice is A. The correct choice is A. Okay. Let's solve question number 12. Question number 12. What least number must be added to 15370 to make it a perfect square? So this time it is same as question number 11, but the number is 15370. So we have to do the long division for finding the square root of 15370. The periods are 70, 53 and 1. We start the long division method. Obviously the divisor will be 1, 1, 1 minus 0. We bring down the next period 53. 53 becomes the dividend, and the next partial divisor becomes 2. And then we have to find the digit x such that 2x, the two digit number 2x multiplied by x is less than equal to 53. This implies x is equal to 2. So x will be equal to 2. This is 2. We have to add 2 to the quotient, and we have 22 into 2, 44. We subtract 44 from the dividend and we get 9. and then we bring down the next period, and we get the next dividend as 970. The next partial divisor will be whatever the quotient is multiplied by 2, that is 24. Again, we have to find the digit x after 4 such that the three digit number 24x multiplied by x will be less than equal to 970. So this implies x will be equal to 4, 16, 17. No, it cannot be 4. It will be because 2, 4, 4. If it is 4, what we are getting 16, 17, 976. It is crossing the value. So x has to be 3, and 243 multiplied by 3 is 729. So x will be 3. X will be 3. We also add the 3 to the current question, and 243 into 3 is 729. We find the remainder, which will be 1, 241, and there are no periods left, so the remainder is 241. Now the question is, what least number must be added to 15370 to make it a perfect square? Okay, so this implies we know that what we will have is the number of 123 will lie between given number 15370 will lie between the square of the square of the quotient, that is 123 square, and the quotient plus 1 square, that is 123 plus 1 is 124 square. So this will imply that this number to be added to make a perfect square, will be equal to 124 square minus 15370. Now we have to find what is 124. Now this the squaring of a number, you should be very familiar and quick to find the squaring of a number 124. Now for 2-digit number, to find the square of a 2-digit number, you have the column method, and the diagonal method, using the diagonal method, which I have not understood and also I have not discussed, the diagonal method can be used to find the square of numbers of any number of digits. I will try to understand that diagonal method, and create a video in the near future. But as of now, I know that 124, instead of multiplying we know that now 124, using the whole square formula, a plus b whole square, I know that 124 is equal to 120 plus 4. So 124 square whole square will be equal to 120 plus 4 whole square. Now this is a plus b whole square formula, and the formula is a square, that is 120 square plus twice a into b plus b square, that is b square is 4 square. Now 120 square is 12 square is 144, and we have 1 0, so in the square there will be 2 zeros, plus 2 into 120 into 4 is how much? It is 480 into 2, and we have 16. So this is 14400 plus 960 plus 16. So this is equal to 6, and then 7, and then 13, 13, and then 2, 2, 3, 7, 6. Let me quickly check if I am right or wrong. This is 6, and then we have 7, and then we have 13. No, I think I'm wrong. So we have to add 14400, 960 and 616. So this is 6, 7, 13, 5, 1. So so this is equal to 124 whole square is 1, 5, 3, 7, 6, and minus we have 1, 5, 3, 7, 0. So this is clearly 6. So the least number that must be added is 6. So the choice is B. Choice is B. Okay. Let's do question number 13. We have to find the square root of the decimal number 0.9. Now the method, I will show both the method that I have discussed in the very recent video about finding the square root of decimals and fractions. Let's first solve that using my method, and then I will solve a direct method using long division method that deals with finding the decimal square root of a decimal numbers. Now the method I have used for solving or finding the square root of a decimal number involves converting the decimal number into a fraction. So the denominator will be a power of 10, and that power of 10 has to be an even power of 10, and accordingly we have to adjust the numerator. So the numerator will be a whole number, and we find the square root of a whole number, and then we divide the final square root by the power of 10, and that power will be the power of the given decimal number, the power of 10 in the given decimal number, that power divided by 2. Let me solve it, then you will understand. So in my method, I had 4 steps for solving for finding the square root of a decimal number. So the given number is 0.9. I will first convert it, express it as a fraction. So this will be 9 by 10. Now I see the denominator is not an even power of 10, it is 10. Power is 1, so 1 is odd. So I have to make the denominator even power of 10. So I will multiply the denominator with 10, and the denominator will become 10 square, and I will also multiply the numerator with 10. So this becomes 90 by 10 square. Now I have in the denominator even power of 10, that is square. Now I will find the square root of 90. 90 is a whole number. I will find the square root of 90 using the long division method. So 90, we know we will have a single period. Okay. Now here also we will have to consider decimal. We will have to consider the decimal point. So the decimal point will anyway come into the picture. We have to deal with the decimal point. So let me okay. So let's say we are finding the square root of 90. So 90, we have a period, single period, that is 90, and so obviously the divisor will be 9. We have 9, 81, and the remainder is also 9. And since there are no more periods, what we have to do is we have to put a decimal point in the quotient as well as in the given number, and we will add, let's say, one period of zeros, and we will bring down those period next. Those period, that is period of zeros we have. So the next dividend becomes 900, and the next partial divisor will be whatever the quotient is, ignoring the decimal point, that is 9 multiplied by 2. We have 18. Now 18. So we have to find put a digit over here x such that the 3-digit number 18x multiplied by x should be less than equal to 900. Now this implies what can x be? This implies x should be such that the largest x, always remember when you are doing the long division method, and if you are finding the x, the digit x, it is always that you have to find the largest digit x such that 18x, the 3-digit number 18x multiplied by x should be less than equal to 900. So the largest x will be it cannot be 5. So 25, no 25, so has to be 4 because 4 and 184 multiplied by 4 is 16, 33 and 736 and 736. Okay, because it cannot be 4, it cannot be 5 because 185 multiplied by 5, it will exceed 900. So 185 multiplied by 5 is 25, 40, 42 and 925 is exceeding 900. It cannot exceed 900. So x is 4. So we have over here x is 4 and 4 will also get appended to the current question. So 4 and 184 multiplied by 4 is 736. 736. We subtract from the dividend 900 and we get the remainder as 4, 164. 164. Now so far in the square root we have 1 places of decimal, that is 9.4. Now you have to see the choices. In the choices, depending on the choices, how many places of decimals are there in the choices. Choice D is 0.94, it is 2 decimal places. Choice C is 0.33, it is 2 decimal places. Let's see. Oh, why? Okay. Okay, so the number is 0.9. Don't immediately think that it will be some kind of 0.3 or 0.03. It will not be the case. So it is a tricky question. You have to solve it very carefully. Okay, so I have 164 as remainder and there are no more periods. Now if you want to find the square root of 90 with more places of decimals, so far we have 1 places of decimals. That is, after decimal point we have found 1 digit. We have found 1 digit, 4. So the current square root is 9.4. If you want to have more places, more digits after the decimal point, then what you do is you add another pair of periods, another period of zeros. I am adding another period of zeros, and I will bring that 0 over here, and I have 16400, and the next partial divisor will be whatever the current question is, that is ignoring the decimal point, that is 94 multiplied by 2. So that is 188. 94 multiplied by 2 is 188. Now again I have to find the digit x such that the 3-digit number, 4-digit number 188x multiplied by x is less than equal to 16400. What can x be? The largest x. So x will be can it be 9? No, 9, 72, 60. Let's see if it works with 9 or not. 1889 multiplied by 9. So 9981 and 7280 and 7280 70. No, it is exceeding. So therefore with 9 it is exceeding. So x has to be 8. And let's see what is 188 8 multiplied by 8. This is 64 and 64 and 64 70 again 64, and then we have 71 and 15. So x will be 8, x will be 8, x will be 8, and 8 will also be appended to the current question, that is 9.4. It will be appended, and 1888 multiplied by 8 is 0.5104. Now at this point you can find the remainder, but remainder will not be really needed. So even but still let's find the remainder. Let's find the remainder. This is 1296. So the square root up to 2 decimal places is, so we see that the square root of 90 up to 2 decimal places is 9.48. Okay, now this was the square root of 90, but remember the given number was 90 by 10 square. So the square root of the actual number 0.9 will be the square root of 90, that is 9.48 divided by 10 to the power. The power will be 2 divided by 2 divided by 2. That is in the original decimal number it was 0.9, and in the fraction form the denominator was 10 to the power 2, 10 square. So whatever the power was, whatever the power of 10 was, that power divided by 2. So basically we have 2 divided by 2, which is 9.48 divided by 10, which is equal to 0.948. And if you consider up to 2 decimal places, all the choices are up to 2 decimal places, this is equal to 0.94 up to if you want to round off 2 decimal places, we can say that the square root of 0.9 up to 2 decimal places is 0.94. So the correct choice is D. The correct choice is D. Now let me first complete all the questions. Then I will come back to this question again, and I will solve it in a different way, directly using without in a little different way, using directly the long division method. Directly using the long division method. You can use whichever method is appropriate to you, whichever seems to be easier to you. Okay, let's solve problem number 14. Problem number 14 is, we have to find square root of 0.1. Now, okay, this time let me solve the problem using not the way that I discussed in my theoretical video, and also I solved it for the problem number 13. I will solve this directly using the long division method. Okay, so you have a decimal number which is 0.1, whose square root you have to find. So you have 0.1. The idea is that after the decimal point, you add required number of zeros, so that you add required number. Now you have to see the choices. Now clearly you can understand that the square root of 0.1 will never be 0.1 or 0.01. It has to be, from common sense, we can easily answer this question. It has to be choice C, that is 0.316. But let's see anyway how we are getting 0.316. Now we can see that in the choice C there are 3 decimal places. Now the idea is that whenever you are finding the square root of a decimal number, if you are asked to find the square root of a decimal number up to 2 decimal places, then ideally after the decimal point you must have 3 periods. You are asked to find the square root up to 2 decimal places. So square root up to n decimal places, let's say, where n could be 2 or 3, or it could be 4. Usually it will be 2 or 3. Square root up to n decimal places will imply creating n plus 1 periods after decimal point. In the decimal number, you have the decimal point. After the decimal point, you have to add as many zeros so that you have n plus 1 periods. Now in this problem, we are not given any we are not given n, we are not told that up to how many decimal places we have to find the square root. Seeing the choices in the given choices, we can see that there the choice C is 0.316. It has 3 digits. So ideally, I will try to find. Ideally I will try to find 3 places of decimals. I should find the square root of 0.1 up to 3 decimal places. For that, I have to create 4 periods. I have to create 4 periods. Now, how do I create 4 periods after the decimal point? I will add as many zeros so that 4 periods are created. As simple as that. I added 1 zero, so after decimal point, 1 period is created. I add another 2 zeros. Second period is created. I add another 2 zeros. Third period is created. I add another 2 zeros. The fourth period is created. Now I can see that in the given number, I have after the decimal point 4 periods created. Now I have to perform the long division method. Okay. So, and definitely after before the decimal point there is only 1 0, so that will be only the a single digit period 0. Obviously, we have to start from 0 because the first leftmost period is 0, so it will be 0 0. And since and so 0 multiplied by 0 is 0 and the remainder is 0, and we have exhausted all digits before the decimal point, so we will add the decimal point to the question. Now we will bring the next period and we get 10. So 10 0 1 0, that is 10, now becomes the next dividend, and the next divisor will be whatever the quotient is, ignoring the decimal point, that multiplied by 2. So 0 multiplied by 2 is 0. Okay, 0. Fine. Now we have to add a digit over here such that the 2-digit number 0x, which is basically x, multiplied by x, has to be less than equal to 10. So this implies obviously x will be 3. So x will be 3, and 3 will also be appended to the question, and 0 3, that is 3 multiplied by 3 is 9. We subtract 9 from the current dividend, which was 10, we get 1. Now we have still more periods left. We bring the next period down and we get 1 0 0 as the next dividend. Now the next partial divisor will be whatever the quotient is, ignoring the decimal point, multiplied by 2. So 3 multiplied by 2 is 6. Now I have to again find the digit x such that the 2-digit number 6x multiplied by x will be less than equal to 100. So this obviously implies that x has to be 1. So x will be 1. So x will be 1. So 1 will also be appended to the question, 1, and 61 multiplied by 1 is 61, that will be subtracted from the dividend, and we have remainder 39. Okay. Now at this point of time, it is not necessary to carry on with the long division method because we have already understood that the answer will be choice C. For solving this kind of MCQ, you can obviously it was not even necessary to do the long division method. You could have easily selected choice C. For solving MCQ or any competitive examinations, you have to be very smart in answering the question. So it was not at all necessary to do the long division method. I am just doing it for the sake of concept clarification. Okay, so I have remainder 39, and I have the next I will bring down the next period and I have the next dividend as 3900. And the next partial divisor will be whatever the current quotient is multiplied by 2, ignoring the decimal point. So 31 multiplied by 2 is 62. And now I have to find the digit x such that 6 to x, the 3-digit number 6 to x multiplied by x has to be less than or equal to 3900. And I guess this should be x should be equal to 6. Let's see what is 626 multiplied by 6. 626 multiplied by 6 is 36, 15, 37. Okay. So we will have 6 over here. 6 will get appended to the quotient, and 626 multiplied by 6 is 3, 7, 5, 6, and the remainder is 4, 4, 1. And we have done the question, the square root of, we have the final square root is, so we can say that square root of 1 is equal to 0.316. So this was the directly how do we find the square root of a decimal number. The idea was if we, first you have to decide up to how many decimal places you want to find the square root. If you have to find the square root up to 2 decimal places, then after the decimal point in the given number, you must have or create, if it is not there, create 3 periods. For 2 decimal places of square root, you have to create 3 periods after the decimal point in the given decimal number. And if you are asked to find the square root up to 3 decimal places, you have to create 4 periods after the decimal point in the given number by just appending zeros, that is periods of zeros. Okay. So question number 14, the answer is obviously choice C. Okay. Question number 15. Question number 15 is square root of 0.9 multiplied by square root of 1.6. Now, the basic idea of finding this kind of the product of 2 square root is that if you see that you cannot easily so if you have, the idea is that root over x multiplied by root over y, you should this is equal to, we know that root over x into y, where x and y has to be positive numbers. For positive numbers x and y, we know that root x multiplied by root y is equal to square root of x into y. Now, if you are given an expression of the form of the product of 2 square roots, if you can find the square roots easily, then you can find them and then do the final product. Otherwise, you use this formula. You find the product of the numbers inside the square roots, so whatever the number comes out to be, and then you see if you can find the square root of that number. Now, if I quickly do now 0.9, if 0.9, I know that its square root based on this paper. If you are solving this paper, I have already found in the for problem number 13 that the square root of 0.9 is 0.94. I know that, but 1.6, the square root of 1.6, I do not know. So it is all before. So if you see that the number inside the square inside the square root, you cannot immediately find its square root. Then always try to see what is x into y. So 0.9 multiplied by 1.6 is 54 and 144, and you know that okay, 144 actually it is 1.44. Why? Because 0.9 is 9 by 10 multiplied by 1.6 is 16 by 10. So this is equal to 144 by 100. Now we know this is we know that 144 by 100, its square root is easy to find. So instead of finding the individual square roots, we will find the square root of their product inside the numbers. So we will use the formula, this formula, we will use this formula, and we will say that this is equal to the square root of product of 0.9 and 1.6. This we know is 9 by 10 multiplied by 16 by 10. This is equal to 144 by 100. 144 by 100. And also, so now we have this. And there is another properties. These are algebraic identities you can consider for square roots, is for fractions, is that square root of x and y, where x and y are some positive numbers, is equal to square root of x divided by square root of y. If you are given an expression, if you see a fraction inside a square root, and in the fraction you see both the numerator and the denominator are perfect squares, which in this case for the problem 15 we can see 144 is a perfect square, 100 is a perfect square. Then you can write the square root of x by y as equal to square root of x divided by square root of y. So I will write it as square root of 144 divided by square root of 100. So this will be equal to 12 by 10. This is equal to 1.2. So definitely the correct choice is A. Correct choice is A. No, sorry. The correct choice is not A but B. The correct choice is B. Okay, let's do problem number 16. We have to find square root of 288 divided by square root of 128. Now clearly we know that 128 is not a perfect square. Also 288 is not a perfect square. So the idea is that so again, when you are given an expression of the form square root of x divided by square root of y, where obviously x and y are positive numbers, when you see that x and y, none of the x or y are perfect squares, then express it as square root of x by y, because if you x by y can have some cancellation, and the value and the x by y after cancellation, you may see, it may come out, it can be the case that the fraction x by y will be such that the numerator and the denominator are becoming perfect squares. So the idea is, when I am seeing that 288 and 128 are not perfect squares and it is of the form root x by root y, I will try to write it as square root of 288 by 128, and now I will try to do some cancellation with 288 and 128 and see what it turns out to be. In most cases it will be of the form a by b, where a and b are coming out to be perfect squares. Now let's see what is 288 divided by 128. I can see it divides, both divides by 4, so 72 and 32, and then I can see 4 divides 32 by 8, and 4 divides 72 by 18. So 2 divides 8 by 4 and 2 divides by 9. So this is coming out to be 9 by 4. You see, now it is coming in the form, after simplification, simplifying the fraction 288 by 128, the simplified form is 9 by 4, and both the numerator and the denominator 9 and 4 are perfect squares. Now we can split it as square root of 9 by square root of 4. This is equals to 3 by 2. So the correct choice is C. Okay, let's do problem number 17. Problem number 17. We have to find the square root of a mixed fraction. Now, whenever you have a mixed fraction, always convert the mixed fraction to a improper fraction. So, 2 and 1 by 4 is 9 by 4. This was really easy. Now, we know we have a fraction, square root of a fraction. There in the fraction, both the numerator and the denominator are perfect squares. 9 is a perfect square, 4 is a perfect square. So, we will write it as the square root of the numerator of the fraction divided by the square root of the denominator of the fraction, and this is 3 by 2. This is 3 by 2. Okay, so 3 by 2, but the answer, all the choices are given in the mixed form. So 3 by 2 is nothing but, if you convert it in the mixed fraction, this is 1 and half. So the choice is B. Correct choice is B. Okay. Let's do problem number 18. Problem number 18 says which of the following is the square of an even number? Now, we know that the square of an even number is an even number and the square of an odd number is an odd number. So the question is, which of the following is the square of an even number? So if we are taking the square, we know that A square equals to B if we know that if A square is equal to B, this implies that A odd will imply, B odd, if B is odd, if we have if the square of A is equal to B, that is B is a perfect square and B is the square of A, and if A is odd, yes, I was right, if A is odd, this implies that if A is odd, this will imply B is odd, and A even will imply B is even. Now, in the given choice, so it is saying which of the following is the square of an even number. Now, the square of an even number will obviously be an even number. So, from the choice, we have to select the number which is even. So, obviously, the correct choice is A, as 196 is the even number. Okay, question number 19. Which of the following is the square of an odd number? So it's similar. We have to select the choice which is an odd number, and obviously we see the odd number is 1369. All other numbers are even. D25, any number ending with 0 is even, and any number ending with 6 or 4, any number ending with an even digit, or 0 is any number ending with a 0 or any even digit is a even number. So the only choice which is a odd number is 1369. So definitely the answer has to be C, because as 1369 is odd number. So with this, we come to an end in solving the problems of MCQ problems of exercise 3H. I hope this video, this solution and the discussion will help you in clarifying your doubts or clarification of concepts of the squares and the square roots of all the concepts of squares and square roots to solve the various kind of problems. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the test paper. I guess it is test paper 3 of the chapter squares and square roots. It will be uh, test paper 3. Uh, there are 13 questions divided into sections A, B, and C. So I will solve that in the next video, and once that is solved, I will create a video on the diagonal method of finding the square of a number, because that is also an important concept which I could not understand as of yet. As of now, I will give more time to understand the method and create a video. And once all these are done, I will then prepare and solve 2 sample test paper, as I always do for every chapter. Those problems will be a little harder problems from what we have been doing from the textbook of author RS Aggarwal. So thanks for watching, and until the next video, take care and bye.